Inside this factory, temperatures rise above 1,500 degrees Celsius, hot enough to melt solid steel into liquid fire. Massive machines operate non-stop. Workers stand beside rivers of molten metal, and one mistake here could be catastrophic. So, how does a steel factory actually work? Welcome to Made in Reality, the truth behind how things are made. Steel is everywhere, from skyscrapers and bridges to cars, railways, ships, and industrial machines. Modern civilization depends on it. But before steel becomes beams, pipes, or massive structures, it begins inside one of the hottest industrial environments on Earth, a steel factory. And the process behind it is far more extreme than most people realize. Every major city in the world depends on steel. Without it, modern construction would be almost impossible. Steel supports massive skyscrapers, holds up bridges, protects vehicles, and powers heavy industry across the planet. And despite being used everywhere, most people never see how extreme its production really is. Everything starts with three key materials: iron ore, coal, and limestone. Iron ore contains the raw iron needed to create steel. Coal is turned into coke, a fuel capable of generating extreme heat, while limestone helps remove impurities during production. These materials are transported into the factory in enormous quantities every single day, because steel production requires non-stop operation. Massive conveyor systems move raw materials toward the heart of the factory, the blast furnace. Steel factories operate on an enormous scale. Thousands of tons of raw material move through these facilities daily, while conveyor systems stretch across huge industrial complexes, feeding the furnaces continuously. Because once production begins, the process can't simply stop. This is where things become intense. Inside the blast furnace, temperatures can exceed 1,500 degrees Celsius. Hot air is blasted into the furnace continuously, creating an environment powerful enough to melt iron completely. At this temperature, solid materials transform into molten liquid. The coke burns intensely, producing the heat needed to separate iron from oxygen inside the ore. Slowly, molten iron begins collecting at the bottom of the furnace. It glows bright orange, almost like liquid lava. And this process never truly stops. Some blast furnaces operate continuously for years, day and night. Standing near a blast furnace is unlike almost any other industrial environment. The heat radiates constantly through the air, while massive machines shake the ground and sparks fill the factory atmosphere. Even from a distance, the temperature can feel overwhelming. Most people never see this part of steel production because standing near these furnaces is extremely dangerous. The heat alone can become unbearable, even from a distance. And yet, workers continue operating only meters away from molten metal. At these temperatures, even small mistakes can become catastrophic instantly. Factories rely on strict safety systems, protective equipment, and precise coordination between workers and machines, because inside a steel factory, there's almost no room for error. But molten iron alone isn't enough. It still contains impurities that weaken the material, so the next stage focuses on refining. Limestone reacts with unwanted materials, creating a substance called slag. The slag separates from the molten iron, floating on the surface and allowing workers to remove impurities from the metal. And this is what transforms raw molten iron into something much stronger: steel. Without refining, steel would become weak and unreliable. Even tiny impurities can affect durability, strength, and performance. That's why modern steel production depends heavily on precision and control. But even after reaching this stage, the process is still far from over. Now, the steel must be shaped before it cools and hardens, and that requires speed, precision, and massive industrial systems. Molten steel is transferred into giant containers called ladles before moving into a continuous casting machine. This machine slowly pours liquid steel into molds. As the steel cools, it begins turning solid again, but the inside remains extremely hot. Massive rollers guide the glowing steel forward, while water cooling systems carefully control the temperature. At this point, the steel still looks almost unreal: bright orange, radiating intense heat and moving through the factory like a river of fire. Cooling steel too quickly can damage its internal structure, which is why factories carefully control temperature during every stage of production. Even after leaving the furnace, the steel still contains enormous amounts of heat energy. At these temperatures, almost nothing can survive direct contact. One accident inside a steel factory can become catastrophic instantly, which is why these factories rely heavily on safety systems, massive machinery, and precise worker coordination. Once partially cooled, the steel moves into rolling mills. Enormous machines compress and shape the material into different forms, such as steel beams, thick plates, coils, pipes, and railway tracks. Each product serves a different purpose. Some steel is used in construction, others in transportation, heavy industry, or even military equipment. And despite the extreme heat involved, the shaping process must remain incredibly precise, because even small defects can weaken the final product. At this stage, the glowing metal finally begins looking like the steel products people recognize every day. Massive industrial machines apply incredible pressure, slowly transforming molten material into usable forms. This is the final transformation from raw industrial process into materials used across the modern world. Steel is one of the most important materials ever created. Without it, modern cities wouldn't exist. Bridges, factories, vehicles, skyscrapers, and infrastructure around the world all depend on steel production. And every piece of steel begins with this extreme industrial process, a process powered by fire, heat, and engineering on a massive scale. From raw iron ore to rivers of molten metal to massive industrial machines operating under extreme heat, steel production remains one of the most demanding manufacturing processes on Earth. And despite the danger, the heat, and the non-stop operation, factories around the world continue producing the material that helps build modern civilization itself. This is what it really takes to produce one of the most important materials on Earth.